Hello everyone, in this video we will take a look at spherical coordinates and I'm going to introduce them. I'm going to show you how to convert from regular rectangular coordinates, so that would be x, y, z, to new coordinates, spherical coordinates, which are rho, phi and theta. So first let's look at the connection between them. So let's take an arbitrary point P with rectangular coordinates x, y and z. Rho is going to be the distance from that point to the origin. So this right here, let me draw that distance. That's rho. So that's easy to understand. Note that this is not the same thing that we had r when we were dealing with cylindrical coordinates, because there we were taking the projection of p onto the xy plane, and then r was the distance from O to the projection. Here the distance is from O to the point itself. The next thing is this angle phi. That's the angle with the z-axis. So this right here, from OP to the z-axis. Now, to get the connection, let's consider a triangle right here. So this right here would be Z. So this triangle is really, it's kind of hard to draw in 2 dimensions, 3 dimensions. But what will happen here is this is going to be the triangle. This will be angle phi. And then the hypotenuse is going to be rho. And then this side is Z. So how do we get the connection? So you all know that cosine phi is just going to be adjacent side, which is Z, divided by the hypotenuse, which is rho. So from here, solving for Z, I get rho cosine phi. So that's your first connection between the spherical coordinates and the rectangular. Now, how about X and Y? So to get that, what you need is draw a projection of the point P to the xy plane. So you'll get some point P prime. And let's say this distance from here to here, from OP prime, let's call it some R. Okay, what would be then theta? Well, theta is the angle with the positive x-axis. So this is theta. And then the x and y coordinates, what are they? Well, let's just consider this triangle right here. So this side would be y and this side would be x, right? It's going to be the same as if you were to draw it x over here. So how do I solve for x and y? Well, let me draw this triangle over here. So then this side is the y side, and then this part is r. So this is also going to be y. And then this angle is theta. All right. So how do what's the connection? So x is going to be, as you already know from polar, r cosine theta. And then y is going to be r sine theta. But what is r? Well, r, this r right here, you can see this from the picture, is the same as over here. But what is that side? What is this side right here? Well, that side is going to be, if you saw that z was rho cosine phi, this other side, because this is the opposite side, so that r is going to be rho sine phi. And so now if we substitute the r, rho sine phi over here and then over here, we will get the connection. So x is going to be rho sine phi cosine theta, and y is going to be rho sine phi sine theta. And then, of course, z equals rho cosine phi. Now, let me show you how to set up limits of integration over some common three-dimensional solids. So first, the whole sphere. So let's take a look. So first, we're going to take a point on the sphere. So I'll draw that point, and let's call that point P. Now, we want to find out what would be the limits if we wanted to integrate over that whole sphere. Well, if you connect the origin with point P, and make sure that your angle phi, which will be the angle with the z-axis, and your angle theta, which would be the angle with the projection over here, that would be theta, right? What we need to do is first fix phi and theta and think about how rho will change. So let's say the sphere, as you can see, has radius of 2. So then rho will go from 0 to 2, right? So you can see that if you go right here, this is where it's 0, and then this is where it is going to be, since it's on the sphere, that's going to be 2. How about the phi? Okay, so let's draw over here on the top of the sphere. This is where the angle phi will be 0, and then we'll just keep going around the sphere all the way down over here and stop right at the bottom. So the angle phi at the on top over here, when the point was on the z-axis, the positive part will be 0. And then as you go all the way around and go down over here, this is where the angle is going to be pi with the positive z-axis, right? Okay, so then phi is going to go from 0 to pi. Okay, so if you draw this, think about it this way. So this is your z-axis. So if we start over here, that's what the angle with the z-axis is 0. And as you keep going around, then the angle is going to be pi. Okay, finally, what we want to do is when we set up the limits over the sphere is figure out what about theta. So theta is responsible for moving this way, right? So that will just be all the way around. So from 0 all the way to 2 pi. So this is going to be 0 less than or equal to theta less than or equal to 2 pi. Okay, so that's the whole sphere. How would that change if we only want to set up the limits over the top hemisphere? So here, the rho will be the same, right? Because you're just going to connect from the origin to some point P on the sphere. So this is going to be your rho. So that's going to go again from 0 to 2. Now, the angle phi, that's going to change because when you're on the top over here, then it's 0 with the z-axis, and then you go all the way up to here, right? And so it's not going to go all the way down. It's going to stop at pi over 2. So your angle phi is going to be from 0 to pi over 2. Now, theta is still going to go all the way around. So theta will just be starting at 0 maybe and then going around. So starting over here, right? Starting at 0 and then going all the way around back to the x-axis. So this will be 0 to 2 pi. Okay, now how about if it's just the first octant? So you will see that sometimes the questions say first octant. What that means is that all coordinates in the first octant are positive. X is positive, Y is positive, Z is positive. So let's see how the rho, phi, and theta change for that. Okay, so again, let's pick a point somewhere. Well, I want to pick some maybe blue color here. So this is your point. P. So again, rho will change from 0 all the way till you are on the sphere, and let's say radius of the sphere is 2. So rho will change from 0 to 2. Now, how about angle phi? So on the top over here, that's going to be 0, and then we go all the way down over here and stop. So phi is going to go from 0 to pi over 2. Finally, what about angle theta? Well, angle theta is the angle with the x-axis. Well, that only gonna go from 0 to pi over 2, right? Because you don't go all the way around. So that's gonna go from 0 to pi over 2. So that's setting up if it's just the first octant. Finally, I call this an ice cream solid. The reason being is that it looks like a cone and it looks like there is a scoop of ice cream on top. So what happens here? So first of all, the cone will have equation z equals square root of x squared plus y squared. And let's say your sphere has coordinates x squared plus y squared, formula for the sphere, x squared plus y squared plus z squared equals 4. So this is sphere of radius 2, right? That's sitting on top. So how do we set this up? How do we set up the limits? Okay, so let's think about that. So let's take a point. Okay, how would rho change? So again, this is 0 and it goes all the way to 2 because the radius of the sphere is 2. So that's gonna be your rho limits. Okay, and so that's gonna go to 2. Now, what about phi? Now, the angle phi is the angle with the z-axis. So when you are over here, the angle is 0, but then it stops right here. It doesn't go any further because the cone is going to prevent it from going further. So what we need to do is figure out what's going to be the angle of this cone with the z-axis. So what's the cone equation in spherical coordinates? Okay, so remember that z in spherical coordinates is rho cosine phi. And then x squared plus y squared, when you look at the connection over here that I was defining right here. So if I square x and y, then I'll get rho squared sine squared, rho squared sine squared, and then I'll have cosine squared and sine squared. So if I add x squared plus y squared, you can pretty easily show, because of the first trigonometric identity, that this is just rho squared sine squared phi. So what that means is that this cone, this rho squared sine squared will become under the square root. So that's rho squared sine squared phi. When you take the square root, you will see that you'll just get rho sine phi. And so rho and rho can be canceled. And for the cone, sine phi and cosine phi are the same. So hopefully you know that the angle for which sine and cosine are the same is really pi over 4. So this cone is not going to go all the way to, let's say, pi over 2, whatever, but it's going to stop right here. So this angle, the maximum it's going to go to from 0 to pi over 4 for this cone. Okay, so this is the rho limits. So phi limits are going to be 0 to pi over 4 for the cone. Finally, what about theta? Well, theta is still responsible for going all the way around. So you're going this way right here, and you're going all the way around. So theta will still be from 0 to 2 pi. So 0 less than or equal to theta less than or equal to 2 pi for the ice cream